Hello, self-isolating sixth graders. Welcome to Chapter 3, Lesson 4. This is week 6 of distance learning. Can you believe that? 6 weeks of this. So many of you are doing so amazing. Absolutely keep it up. All right, buckle up. This is going to be a bit of a long one, but, I like this stuff. So, here we go. We have to work with a couple of definitions today. The main focus of this lesson is going to be on sedimentary rock, our second kind of rock. Igneous rock, if you remember, is when rock solidifies from a liquid. When you get liquid rock to freeze, even though that's at several thousand degrees, you get igneous rock. Well, sedimentary rock forms in a very different way. This is formed by layers of sand, silt, clay, or gravel. Those bits are cemented and compacted together. We are going to break down this definition looking at all of that. But for now, what I really want you to focus on is that word layers. Sedimentary rock is very, very recognizable because of its layers. To make sedimentary rock, you need a couple of processes. The first is weathering. The definition we are going to work with on weathering is when rock is exposed to air, water, and ice, it becomes unstable and it breaks down chemically and mechanically. Later on in a future lesson, we're actually going to look at the difference between chemical and mechanical weathering of rock. Erosion is when sediments move from one place to another. So erosion is not breaking down of rock. Weathering is breaking down of rock. Erosion is just the already broken down bits moving to a new location. All right. And then finally, definition we are going to need to know today goes back to the first quarter, and that is solution. And that is when a substance is dissolved into a liquid. So let's work with these four today. So here we have the very recognizable layers of sedimentary rock. I'm hoping, have seen rock that looks like this all over Cincinnati. Just about all of the rock that is in Cincinnati is sedimentary rock. We do not have a whole lot of igneous rock around here, quite simply because there are no volcanoes or magma chambers anywhere around Ohio. So any igneous rock that you see in Cincinnati is not from here. It was brought here from another location. All the rock around here is sedimentary rock. So everywhere you drive, you will see these very recognizable layers everywhere. Anywhere that we have cut into a mountain or a hillside, there are no mountains around here, work with me. Anywhere where we have cut into a hill in Cincinnati, where rock is exposed, you will see the very recognizable layers. Each layer has kind of its own story as far as how it got there. The deeper you go, the older it is. And then all of this took millions and millions and millions of years to make. So appreciate it. Now, to give you an idea of why Cincinnati is mostly sedimentary rock, here we have what's a picture of the Earth, of what the Earth looked like 458 million years ago. This is from the Middle Ordovician period during the Paleozoic era. Anyway, this red dot right there, that is Cincinnati. Cincinnati, as you can see, used to be south of the equator. And at the time when all of the rock around us was forming, Cincinnati was actually underwater in the middle of an ocean, the Iapetus Ocean. So that is why all of the rock that is in Cincinnati is sedimentary, and all of the fossils in that sedimentary rock tend to be sea creatures. And you can go to a lot of different hillsides and go fossil hunting here in Cincinnati, and they will always be sea creatures because all the rock that formed around here is around 458 million years old, and it all formed at the bottom of an ocean. And all of the fossils in Cincinnati are sea creatures. All right. So anywhere where you see sedimentary rock, you are looking at layers and layers and layers. If you go to the Grand Canyon, you will see how the Colorado River has carved out. It actually has weathered and eroded away all kinds of rock, exposing all the different layers. Each one of these layers is a different color because of the mineral composition in those sediments. All right. So here is the basic process. Existing rock is weathered. So it's existing rock is exposed to weather of some sorts. Freezing, rain, wind can even break down rock. So rock is going to be broken into tiny little bits of rock that break off of the big rock. Those tiny little bits are called sediments, and that gives us our name, sedimentary rock. Sedimentary rock is made out of tiny little bits of broken rock from other rocks. Now, the different sediments are going to have names based off of their size, and that's going to help us classify sedimentary rock. So, there is an actual scientific difference between sand, silt, clay, gravel, things like that. And it all comes down to size. So gravel can be broken down into boulders, cobbles, and pebbles. And you can see their size ranges right here. So technically, anything that is 256 millimeters or bigger is a boulder. So really something that's only about 25 centimeters, so about 10 inches. So somewhere in the neighborhood of a 10-inch rock or larger is scientifically called a boulder. Um, Pebbles are between 2 and 64 millimeters. Then after gravel comes sand, and sand is anywhere from 2 millimeters in diameter down to 0.0625 millimeters. Anywhere from anywhere between 2 thousandths and 625 hundredths millimeters is called silt. And then anything much, much smaller than that is clay. So actually, most of the soil in Cincinnati tends to be clay-sized particles, which is really bad for gardening. Anyway, so we're going to use these different sizes to give us different kinds of sedimentary rock. All right. So after the tiny little bits of rock are created, the sediments have been weathered off of a larger rock. They now need to be moved to a new location. We call that erosion. Sometimes erosion will carry something a short distance. Sometimes it will carry it hundreds and hundreds of miles. At the end, whatever is causing these sediments to move will stop. Maybe it's like it's at the bottom of the hill or the bottom of end of a river, something like that. These sediments are going to be stop moving and they're going to start to stack up in a pile, and we call that deposition. Now, if you look at the word deposition, you may recognize a root word, and that root word is deposit. The word deposit means to leave something somewhere. When you put money into your bank account, you are making a deposit. So up at the top, we have very large rock, and then wind, rain, freezing, things like that are going to start breaking off little bits of rock that we call sediments. Those sediments are going to move because of wind or water carrying them, or sometimes just gravity. When those sediments move to a new location, we call that erosion. And then down here, there's nowhere else for them to really move to, and so they begin to stack up in a pile, and we call that deposition. They are being deposited at the bottom. Then we still don't have sedimentary rock. They are just a bunch of sediments in a pile. They need to now go through compaction and cementation. Compaction is the squeezing of sediments together. As more and more layers and layers of sediments stack up, that causes an awful lot of pressure, and that pressure will begin squeezing the sediments together. Sometimes, if the sediments are small enough, that pressure just by itself can actually squeeze the sediments to combine into one solid rock and create sedimentary rock. More often than not, though, we need cementation. And here we have dissolved minerals in a solution. There's our solution word. And those dissolved minerals in a solution are going to flow into all the tiny little spaces between the sediments after compaction. Eventually, the minerals will recrystallize out of their solution, start grabbing onto all of the sediments, and that's going to act as a cement that holds all of the sediments together. So you need after deposition, you need compaction, squeezing them together, and cementation, dissolved minerals coming out of their solution to act as a cement to glue it all together. So we have sediments. They have all been deposited, but they're all just individual sediments. Compaction, a lot of pressure from above, will kind of squeeze them together. So notice that the spaces in between the sediments has decreased. That's what compaction does. But that's not enough to get these to stick together. Now we're going to have a solution kind of flow into all these little empty spaces, recrystallize, and then form one solid rock. And again, just another picture. You have individual sediments after weathering and erosion and deposition, and then compaction and cementation will give us sedimentary rock. Whew! That is how most sedimentary rocks are formed. There are other ways. I told you to buckle up. This is going to be a long one. So the definitions or the subcategories of sedimentary rock that we need to work with are clastic, organic, and chemical. Let's start with clastic. Clastic sedimentary rocks are the classic sedimentary rocks. That whole process that we just described, we just talked about clastic sedimentary rocks. So clastic sedimentary rocks are made by weathering, erosion, deposition, compaction, and cementation. Once we have gone through those 5 steps, we can now group or name them by the size and shape of their sediments. So if the sediments were gravel, they were boulders, cobbles, pebbles, or granules, we will call that either conglomerate or breccia, depending on the shape of the gravel. If clastic sedimentary rock was made out of sand particles, we call it sandstone. And if it was made out of silt or clay, we call that siltstone, shale, or mudstone. So we can have a couple of different categories of classic sedimentary rock, and that depends on the size of the sediments. So here we have them in picture form. So conglomerate and breccia are made out of gravel. Okay. Sandstone made out of sand particles, and then shale and mudstone down here made out of either silt or clay. Let's take a closer look at conglomerate or breccia, because there is a difference. So conglomerate and breccia are this all made out of gravel sediments. They are 2 millimeters and larger, and they are going to be broken into 2 different categories based off of shape. If the sediments are more weathered and round before being compacted and cemented, we have a conglomerate there on the left. And then if the sediments, the gravel, was compacted and cemented before the sharp pointy bits could be rounded off by weathering, then we call that breccia. So if you look at conglomerate and breccia side by side, you should see that conglomerate sediments are roundish and breccia sediments are pointy. So here we have a clastic sedimentary rock that has rounded sediments, and they are very large, so we call it a conglomerate. Breccia is clastic sedimentary rock, but with pointy sediments, and we call that breccia. Whew, okay. The second subcategory of sedimentary rocks is organic. Yay! Another use for the word organic. Isn't 6th grade science so much fun? Organic sedimentary rocks are made out of substances that used to be organisms. So yeah, if you take organisms and then you make a rock out of them, you have an organic sedimentary rock. The two classic examples are coal and limestone. Let's take a look at coal. So, millions and millions and millions of years ago, there were plants, mostly plants, some animals too, but mostly plants. And they died. Oh. When they die, they fall into a very high moisture area, usually some sort of lake, pond, something like that. Not moving water, very, very still water. That tends to be a very low oxygen environment and is not good for decomposition. So these organisms are going to die, fall into the water, and then not really decompose too well. That's going to form a substance called peat. Here we have a peat bog. So as you can see, it's a very wet environment, and the water isn't moving. All of this here is peat. It's a bunch of, it's just a big, big, big pile of years and years and years and years and years of organisms dying and not really decomposing too well. So this is a very highly organic matter area. We can actually use this as a fuel source. People will actually go to peat bogs and carve out peat bricks. It's like really thick mud, but it's instead of being soil so much, it's actually just very, very decomposed plant matter. Well, if people don't dig out the peat, eventually more and more and more sediment forms on top of it. And so now you've got a layer right here that is being compacted. So it's very highly organic matter being compacted. And that will form a substance called lignite. Years and years and years of more and more pressure, and you can get a type of coal called bituminous or subbituminous coal. And then after a lot more time and a lot more compaction, you can get a very condensed form of coal called anthracite. So whenever you see coal, you are looking at plant matter that has been semi decomposed and then compacted over a very long period of time to form coal, a rock. So this is a rock made out of very compacted, semi decomposed plant matter. Kind of cool. You can actually see in sedimentary rock, and again, you can. It's very recognizable because of its layers. So here we have a big coal layer, and then a long period of time where rock sediments got piled up on top of that, compacted and cemented into a new rock. Then another period of time where this was near a water source, and a new layer of coal formed, and here's the rock that formed on top of that. And you can see other thinner little layers. So this kind of tells the story of the history of the Earth. And there's a little bit of a period of a lot of plant matter, not a lot, little bit, not a lot, a little bit more, not a lot, a good period of time of coal formation. Then a big long period of time where there was very little coal formation going on here. There was not a very wet and organic area. And then it reverted back to that. So geologists can actually look at sedimentary rock and start telling you the story of the history of that part of the Earth and what was going on the Earth at that time. So sedimentary rocks are excellent for figuring out what was going on in the Earth at that period of time. So back to this. We've got different types of compacted organic matter: peat, lignite, bituminous, subbituminous, and anthracite coal. And really what it comes down to is how compacted it is. In picture form, you can see peat is not very compacted, but it's very clearly organic matter. With a little bit of compaction, peat can become lignite. As you can see, it's already kind of a rock. Then subbituminous and bituminous coal is kind of good coal, but the best coal is anthracite. Very, very compacted, very, very rich in energy. All right. We need to discuss the difference between coal, charcoal, and charcoal briquettes. You do not cook with coal. Charcoal is not a rock. So let's get this sorted out. Coal is compacted plant matter and is a rock. All right. Coal is a rock. Charcoal is mostly burnt wood. If you take a big piece of wood and you burn it in a low oxygen environment, it will mostly burn but leave behind a lot of carbon. And we call this mostly burnt wood charcoal. If you take mostly burnt wood, charcoal, and then smash it to a powder, add a little bit of glue, you can shape it into briquettes. These are both just mostly burnt wood. Coal is a rock. Wood, rock. Wood, rock. Cook, no cook. Okay. Whew. The last subcategory of sedimentary rocks are the chemical sedimentary rocks. So, chemical sedimentary rocks form when you have a mix of minerals that are all dissolved into a solution. That solution will become oversaturated and start to form crystals. Because the crystals are a mix of different minerals, we call it a rock instead of a mineral because it won't have a definite chemical composition. It is an impure substance. So it forms in the same way that a lot of minerals do, but because it's not a definite chemical composition, we have to call it a rock, which is a mixture of minerals. Now, a good everyday example that you will see in your life is Himalayan pink salt. Some of you may have seen this in your kitchen. Some of you may have seen this at the grocery store. And if you haven't, when you go to the grocery store, look for it and I'll show you what it looks like. So here's how Himalayan pink salt formed. Millions and millions of years ago, the sea became oversaturated with salt and a bunch of other minerals that were along for the ride. It recrystallized into a rock because it was a mixture of minerals, and then it sank because it had a higher density. That formed a layer of rock that was mostly salt at the bottom of the ocean. Now, at the time, India was not attached to Asia. Okay, again, we're going back like 40, 50 million years ago. India was its own little island continent, very similar to what Australia is now. When India went crashing into Asia, that pushed that layer of rock that was deep underwater up into a mountain range. And now we can mine that layer. So let's take a look at that. Here's India today. Okay. India was not always attached to Asia. India was its own island. So here we have somewhere around 50, 55 million years ago. And here's Australia. But here's India. India was its own little island. By the way, if you look, North America and South America were still forming. Looks like the Andes Mountains were about to form. North America and South America were not attached. But anyway, here's India. In this area right here, there was a bit of ocean, and at the bottom of the ocean floor, this is where a lot of this pink salt was forming at the bottom of the ocean. Then India started to move towards Asia, and that started to really squeeze together the ocean floor here, and that started to push up the ocean floor into a mountain range. Then, when India finally did ram with Asia, a mountain range was formed right here, and that mountain range is rock that used to be underwater. And so now in this mountain range right here, the Himalayas, we can actually look at layers of rock that used to be at the bottom of an ocean. So this area right here is where pink salt formed around 50 million years ago and then got pushed up into a mountain range. In that mountain range, we can go actually just start mining the side of a mountain. And here we have a Himalayan pink salt mine. This is in the middle of the Himalaya mountains. It's just a layer. We treat it like any other mine. We just start digging away at it. This is all salt. It's pink because of a lot of the other minerals that were trapped inside that rock. It gave it kind of a pink color. If you went up and you licked the wall, which sixth graders tend to want to do, it's salt. This is just one big layer of salt. People in this part of the world make their living by going up into the Himalayan mountains and breaking off big chunks of salt that are in the mountain. So all of this rock here used to be at the bottom of an ocean, and it formed 50 million years ago out of a solution. So this is a chemical sedimentary rock. Nowadays, you can go to the spice aisle of Kroger, Meijer, Aldi's, wherever you go grocery shopping, look for the salts, and then there will be all kinds of Himalayan salt. So this is a chemical sedimentary rock that formed at the bottom of an ocean, got pushed up into a mountain range as India crashed into Asia so rudely, and then now people mine it, and then now it's in your grocery store. Okay. I think that was my longest one yet. So let's pause here. There's still no book work. Don't ask me about that. Reminder for today's questions, make sure you use the video and find the answer. Don't ask me about questions like, I don't know what this is. It's somewhere in this video. I'm not going to ask you a question that's not in this video. But meanwhile, the Mr. Bogdan and his Himalayan salt block that he got for his birthday wish to say bye-bye.